In this video, we're going to talk about the definition of a function. Now, a function consists of a set of inputs called the domain and a set of outputs called the range, and a rule by which each input determines exactly one output. Now, in a function, each input produces a single output, but different inputs may produce the same output. So I'll explain what I mean by that in just a second here. But first, let me tell you about the way I kind of think about a function. A function is like a machine where you can throw something into the machine and you'll get an output. Something will pop out of the machine. Now, the things you throw into the machine, the inputs, are called the domain. And the set of things that you get as outputs, that's called the range. So for example, we could throw in the number 3 into our machine, and then maybe output the output for 3 would be 4. Okay, maybe another input would be 1, and we would get an output of, say, 7. Now, so far, this is a good machine. It's an actual function. But there would be a problem, though, if when I threw 3 into the machine again, if I got something other than 4. So 3 cannot be associated with two different outputs. I can't throw in 3 and get out 4 one time, then throw in 3 and get out 8 another time. Okay, now one thing that is okay though is I could throw in a number like 8 and get an output of 7. This would be okay. This would still be a function. So in other words, two different inputs, it's okay if they give you the same output. Okay, 1 and 8 both gave me the same output. But what you cannot have is the same input giving you two different outputs. Okay, so let's look at some examples. Which of the following rules describe functions? Part A, it says use the optical reader at the checkout counter of the supermarket to convert codes to prices. So everything at the grocery store has a price. A Snickers bar, for example, might cost $1. Okay, every item in the store has a price to it. So therefore, it is a function. Okay, now what would be a problem is if the Snickers bar costs $1 and then you tried it again and it costs $2. Okay, but that doesn't happen, right? So that would be a problem. It would not be a function. But as it is a function. Okay, so the answer is yes. Now notice it's okay that multiple items in the store cost $1. Multiple different items, that's still okay, but you can't have the same item having two different prices. Okay, another example, enter a number in a calculator and press the x squared key. So for example, if you press 5 on a calculator and then press the x squared key, you get an output of 25. Okay, if you put 7 in and hit x squared, it gives you 49. So yeah, each input gives you exactly one output. Now again, notice two different inputs though, like 5 and -5, would give the same output of 25. Okay, but with each input there's exactly one output. Okay, now another example, assign to each number x the number y given in the table below. So this is kind of saying that if you input -4, you'll get an output of 8. If you input -2, you get an output of 0. Now, is this a function? Well, there's a little bit of a problem here and here. When we input 3, we get an output of 7, and when we input 3 another time, we get an output of 2. So no, this is not a function. Okay, and our last example, D, y equals 5x minus 2. Now we're thinking of x as being the input and y as being the output. Okay, unless it's otherwise stated, if you have an equation that involves x and y, you think of x as the input and y as the output. So is it true that each number x that you plug in, there will be exactly one number y that you get as an output? Yes, that's true. Okay, for example, if you put in 3 for x, y would be 13. Okay, now this last example is kind of important. In example D above, the equation y equals 5x minus 2 defines a function with x as input and y as output because each input x produces exactly one output y. In such a case, we say the equation defines y as a function of x. Okay, it defines y as a function of x. That means x is the input and y is the output. So let's look at these last two examples here. Decide whether each of the following equations defines y as a function of x. Now, y equals minus 3x plus 8. Yes, that does define y as a function of x because you can input x values and you'll only have one y value associated with it. So y is a function of x. The answer is yes there. Now this one is not so clear. Is it true that each x value has only one y value associated with it? In other words, is y a function of x? Well, notice that if x is 9, y could be two different things. Y could be either 3 or -3. So that input gave you two different outputs, so it's not a function. Y is not a function of x. Now, it would be the case that x is a function of y, but usually when we see an equation that involves x and y, we're asking, is y a function of x? Does the equation define y as a function of x? In this case, the answer is no.